guys, it was good to talk to you last week in our Zoom meeting. So what I want to do this week is I want to review for you how to use a protractor, because some of you guys were having trouble last week, and then also how to name triangles and quadrilaterals, because we're going to be continuing that this week, okay? If you ever have questions while you're doing it, you can always look at the Khan Academy posts that I send to you. That guy will explain the lesson. Or you can go to IXL Math and click on a skill, and it can give you example problems and explain to you how to do it there. So you can use those two resources if you need immediate help on whatever I've assigned you, okay? So here's a picture of some llamas that I took a long time ago. And this guy right here, I like to call my right angle llama. And hopefully after I am done explaining to you how to use a protractor and how to measure angles, you will already know, or you will know why I like to call him my right angle llama. Okay, so I'm going to move him aside here. And here I have some triangles. So we're going to learn how to use a protractor on measuring triangles here, okay? So I know some of you didn't have protractors at home, so I provided you with this very, 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 very expensive makeshift protractor here. And this will work just fine, but before I use this, it's a good idea on a triangle here. It might be helpful if you extend the lines or the sides of your triangle, which I noticed some of you did do on your homework. Good job. So I'm going to extend that line there. I'm going to extend the line at the bottom here. And one more right here. Okay, so I've taken the triangle and I've just extended the lines. Now, let's start with this angle right here. And the reason I'm starting with this angle, this is a very important angle for measurement for you guys to understand, okay? So this, where the two lines meet in a triangle, is called a vertex. And when you're using a protractor, it's very important to put the center of the protractor onto the vertex. So I'm just going to bring this down and line it up right about there, okay? And then you'll notice that the line on the bottom here needs to line up with the side of your triangle. So I can't see that because we're kind of at an angle here, but it's lined up exactly like that. Okay, now when I do that, I'll bring this back here, you'll notice that this line comes straight up to about 90 degrees, okay? I hand drew this, so it's not going to be exact, but we're going to say it's 90 degrees. So I'm going to go ahead and write 90 degrees here. And if you look at my protractor, the 90 degree mark is kind of the halfway point. So from 0 to this end here is 180 degrees. And if you take 180 and divide it in half, half of the protractor, or half of 180, is 90 degrees, okay? So we're going to call this angle here 90 degrees. And another way to show 90 degrees, because it's such a important angle here, is to just draw a little square. So if you see a triangle and you see that symbol in the angle mark, that tells you that it's 90 degrees. You never have to measure it because that symbol tells us it's already supposed to be 90 degrees, okay? All right, but let's look at this angle here. This is not 90 degrees, I can tell. So I'm going to go ahead and take my protractor, and I'm going to go ahead just like I did before, and I'm going to line up the center of my protractor with the vertex of the triangle. So I'm going to scoot this down here. And you want to make sure that the bottom line is lined up with the line of your triangle. So I'm going to move it over a little bit there. Okay. And then I can come over here and see where my line extends out. Okay, so it's right about there. Now, it's not exactly on this large line here, so I have to scoot it inward a little bit, but I notice that there are two numbers here I have to choose from on the protractor. So do I choose the bigger number or do I choose the smaller number? Well, that's where the 90 degree angle comes in to help you here. If we think of a little Pac-Man character and we think of its mouth like this, okay? the Pac-Man character's mouth right now is less than 90 degrees. I'm going to draw my makeshift 90-degree angle right here. So this was 90 degrees, okay? And the angle on the little Pac-Man here is smaller than that, or it's starting to close down. So think of it as it's closing down because there's not a lot for it of the little pieces to eat, okay? So if the angle that you're measuring is smaller or less than 90 degrees, this top line goes down, then you're going to use the smaller numbers on the protractor, okay? But if I have a Pac-Man character with a big, wide open mouth, like so, it's got a lot to eat, so it's going to open its mouth really wide. So if I compare that to my 90-degree angle here, all of a sudden this top line gets bigger because there's more to eat. So if that's the case, then I'm going to use the larger number on the protractor, okay? So let's go back to the angle we measured here, and it looks like this angle here is smaller. The mouth is closed, so it means I'm going to use the smaller numbers on the protractor. And there's my dog barking. Okay, I think she stopped right now. So let's go back to our numbers here. So we have 50 and 60. So this angle's a little bit bigger than 50. If this is the 50 mark, 1, 2, 3, it's about, oops, you guys can't see that. Okay, let me come back here. Line that up. Sorry about that. Okay, so come back to here. Here's the 50. We decided that this angle is the smaller size mouth, so it's going to be the smaller number. It's a less than 90 degrees, so I'm going to use the 50. And here's the 50 line, and I'm going to count 1, 2, 3. So this angle is about 53 degrees. Okay, this part right here is about 53 degrees. So we know that this is 90 and this is 53. Now, here's the really neat part about triangles. If you take a triangle and you add all three angles of the triangle, it always equals 180 degrees. So the reason I'm telling you that is because if I take 53 and 90 degrees and add it together, let's do that. 53 plus 90 is 143, right? Check my math. All right, if I add that together, that gives me 140 degrees. And if I know that this plus this plus this angle always equals 180 degrees, I can take what I've already done, the 90 and the 53, and I can add it together, which we've done, and subtract it from 180. Let's do that now. 37. That tells me that this angle right here is going to be 37 degrees. Why? Because adding all the angles of a triangle always equals 180 degrees. So I really only have to measure 2 angles of a triangle in order to get all 3, because the third one, you can just do some math, some calculations, add them, the angles that you measured, and subtract from 180, and you get the third angle. And this looks like an acute angle. It looks smaller than 90 degrees. Look at how small this angle is. So that makes sense. It's a reasonable measurement because it's smaller. If I got something in the hundreds, then I know I'd have to go back and check my math because it's too big. Okay? All right, now, if this is still confusing to you, you can go ahead and replay this part of the video. All right? So I want to do an activity here to prove what I just told you. When you add all the angles of a triangle together, it always equals 180 degrees. Now, I told you on Google Classroom that I needed you to print out this paper here. Let me find it here. This paper here. Okay. So hopefully you did that. If not, you can pause the video and go ahead and print it out. If you can't print from home, that's okay. Just cut yourself a triangle from any piece of paper. Take a piece of paper and cut the corner, like so. Just take a piece of paper and cut the corner, like that. Or you can take the triangle that I have here. It doesn't matter. All right, so now what I want you to do is I want you to tear each of the corners of the triangle. So here's angle B. I'm going to tear angle B off like that. And then I'm going to tear angles C and A. So now I've ripped my triangle into 3 different parts, okay? Now, we're going to prove that when you add all the angles of a triangle, it equals 180 degrees. So if I take my angles, A, B, and C, and I try to put them together, let me move them around here, like a puzzle, like so, what do you notice about, it's kind of hard to see because you're at an angle. Let me move my iPad here and see if I can give you a better view of what's going on here. What do you notice about the 3 angles together? Ah, the bottom is a straight line. Well, if I take my protractor and I put the vertex, or the center of the protractor, on my 3 pieces here, notice that the bottom of them matches the line of my protractor. And we know in a protractor, a straight line is, right here, 180 degrees. So that proves that when you add all the angles of a triangle together, it equals 180 degrees. And it does not matter what size triangle you have, that is true for any size triangle, okay? So if you're a little confused by what I just showed you, you can go ahead and replay the video and make sure you try cutting the pieces and doing it yourself, because sometimes actually doing it does help you to understand better, okay? All right, so that's triangles. Now, for Monday's assignment, I'm going to give you a paper that looks like this. Triangles, all right? And triangles, it says here at the center, it says find the unknown angle measure. So here they give you actually 2 measurements here. You don't even need a protractor. And this one is the mystery angle. And if you were paying attention, there's that symbol that I showed you. We already know what the value of that angle is, okay? Over here on triangle B, they give you 2 measurements of the triangle, and you have to figure out this top one. But you don't need a protractor. Why? Because you can add these 2 together and then subtract from 180 degrees. And lastly here are the 2 measurements, and then you need to figure out the third one, okay? So you're going to do 7, 8, and 9 on this handout, and you don't even need a protractor because we can use calculations to help us figure out the measurement of the third angle. All right, the top part here asks us to classify each triangle. And triangles can have 2 different names, depending on whether you want to name them by their sides or whether you want to name them by their angles. Just like you guys have 2 names. You have a first name and a middle name. Well, some of you. And so maybe sometimes your parents call you by your first name, sometimes they call you by their middle name. Maybe sometimes if they're mad, they call you by your first name and your middle name. So here's what we're going to do. We're going to name triangles or classify them based on their sides. These are the names that triangles have if you want to call them by their sides. And we're going to name triangles based on their angles. These are the 3 names triangles have if you want to name them by their angles. Okay, so what do these names mean? Let's take a look at one of the handouts I asked you to print out, but if you don't have it, that's okay, because you can just look at this one right here. So let's start with this triangle B, cute little B, okay? Now, if I want to call B a name, but I want to name it based on its sides, what I have to do is measure the 3 sides. So let me go ahead and take my ruler, and I'm going to measure here. This is about 4 centimeters. And then I'm going to measure the top side here. This is also about 4 centimeters. And I'm going to measure the third side here, and guess what? It is also 4 centimeters, okay? One way to show this, that they're all the same, is this side is equal to this side, which is equal to this side. So if I put a line on all 3 sides, that's another way to show that all 3 sides are the same. All right, if the sides are all the same, we call that an equilateral triangle. Okay, and I think in your math book on page, let me just find it here, 915, in the key concept section, let me show you what I'm talking about here. Right here. When all 3 sides are congruent or the same measurement, here it's 3, 3, and 3, and then the one that I just measured is 4, 4, and 4, we call that an equilateral triangle, okay? All right, but not all triangles are equilateral. So let's take a look at triangle A up here. And if I measure triangle A with centimeters here, let's measure the bottom. That's about 11 centimeters here, and that's one measurement. And we'll measure one side, another side here. This is about 8 centimeters. So this is a different measurement. And then the last side of this triangle here is, guess what? It's about 8 centimeters. So I'm going to use this same symbol here. That means these 2 sides are congruent or the same, and this side here is different. So when you have 2 sides of a triangle that are congruent or the same, and one that is different, it has a special name. It is called isosceles. Make sure I spell that right. Isosceles, okay? So this is isosceles. All right, and then there's one more name for triangles based on its sides. So let's go ahead and look at triangle C here. Triangle C. I'm going to go ahead and measure all the sides of the triangle. Down here at the bottom, this is 9 centimeters. That's one measurement. I'm going to measure this side here. That is about 11 centimeters. That's a different measurement from this one here. And I'm going to measure this third side. This is about 7 centimeters, and that is different from the other 2. So all 3 of these have different lengths. None of them are congruent. So when a triangle has 3 different measurements for all 3 of its sides, we call that a scalene triangle. Scalene triangle. Okay? All right, so I've given these triangles names based on the measurements of their sides. But triangles can also have names based on the measurement of their angles. So now I'm going to go ahead and measure the angles of these triangles here. And this one, I think you can guess. We don't even need a protractor, but I'm going to do it anyway. If we line this up here, line the bottom along. Hey, it's 90 degrees. I bet you knew that already. So I'm going to put this symbol here, 90 degrees. Come over here. Now, this angle looks small. It looks smaller than 90 degrees. So I'm going to have to use the smaller set of numbers on the protractor. So let me go ahead and extend the line here on my triangle. So it will be easier to use, whoops, that's off. It will be easier to use my very, very, very expensive makeshift paper protractor. Okay, so now I go ahead and I line the center up on the vertex. Make sure that this bottom part is lined up with let's extend this line here so that I can be absolutely sure that this is lined up. Okay, let's go ahead and line the vertex up here and that the bottom is lined up with the side. Okay, now let's come up here to the top. Remember, I said that this angle looks smaller than 90 degrees, so I'm going to make sure that I use the smaller number at the top here, not 140, I'm going to use the 40. And it is a little bit smaller than 40. It doesn't quite hit the 40 mark. So let's subtract here. This is about 1, 2. So I'm going to say this angle measurement is about 38 degrees. So 38 degrees. Okay, so this one is 90 and this one is 38. Now, do I need to measure the last angle? No, I do not, because I already know two of the measurements, and I know that 90 plus 38 equals 128 degrees, okay? And I have to subtract that from 180. Why do I need to subtract that from 180? Because I know if all three of these added together equal 180, and I know two of them, I can figure out the third one here. So let's take 180 and subtract it from 128. We get 52. So I'm going to go ahead and say that the angle here is 52, whoops, not 55, 52 degrees. And that sounds reasonable because that, if I look at that angle, that looks like less than 90 degrees. And so 52 is less than 90. So now I look at my angles here, 52 degrees, 90 degrees, and 38 degrees. And those are all different. They're all different angles. So when all three angles are different, it has a special name. But because this angle here is 90, and I told you 90 is a special angle, it has a special name. It is a right, oops, can't see that, right triangle. And if you look on page 916 in your book, it has a picture. You can see that there. When one of the angles in a triangle is right, and the other two are smaller than 90, which is true for our triangle. This is smaller than 90, it's 38. And this is smaller than 90, it's 52. We have a special name for it called a right triangle. So this triangle has two names. It's scalene, if you want to call it by its sides, and it's also right, if you want to call it by its angles. Okay? Now, let's go ahead to our equilateral triangle here. All right? We said that all three sides were equal, and if we name it by its sides, it's equilateral. But if we want to call it by its angles, we're going to give it a different name. So, just to save time here, I'm going to tell you that when the sides of a triangle are the same, the angles are also the same. All three angles are the same. And I don't have to measure with a protractor because if I know this angle plus this angle plus this angle is 180 degrees, and all three angles are the same, I can divide 180 by 3, and that gives me 60. So all these angles here are the same, and they are 60 degrees. Now, if you don't believe me, I can prove it. Let's go ahead and extend our lines here. And let me take my very, very expensive protractor. And I'm going to put the vertex on the center of the protractor. And I'm going to make sure that my line lines up here. There we go. And look, it's pretty close. Let me look here, show you. It's at the 120 and 60 mark. And we know we're going to use the 60 because this little mouth here is smaller than 90 degrees. So we're going to use the smaller number on the protractor, 60 degrees. All right, so this angle is 60, and maybe you can just take my word for it because this is an equilateral triangle. This is going to be 60 and this is going to be 60, okay? So when all three angles of a triangle are the same or smaller than 90, it has a special name called an acute triangle. When all three angles are smaller than 90 degrees, it's called acute. And 60 is smaller than 90. So this can be called an equilateral triangle if you name it by its sides, or if you name it by its angles, because all of the angles are less than 90, it's called an acute triangle. Okay? All right, which leaves us to this triangle here. Actually, I'm running out of space here, so I'm going to give you a new triangle here. I'm going to use triangle D. Triangle D because it's got a nice big obtuse angle here, okay? So remember, if I look at this angle here, look at how open that mouth is. It's really wide open. Let me get a better picture of that. There, it's really wide open. So I know that on a protractor, I'm going to have to use the larger numbers here. So let me extend these lines so we can measure the angle of this very wide mouth here. Okay? So let me put my center of the protractor on the vertex here. And let's measure it this way here. Put it on the center. You can see that. No, let's do it this way. Okay, center of the protractor here. And I'm going to make sure that my bottom is lined up with the 180, like you can see there. And at the top, sticking up just a little bit, is where the line extends. And it looks like it's right on this line here, okay? So there are two numbers that we're going to look at. Here's 50 and 30, here's 55 and 135, halfway between. So I already looked at the angle and I knew it was larger than 90 degrees. So I'm going to use the larger number. So if this is 130, this is 135. So the measurement of this angle here is going to be 135 degrees. And that's reasonable because it looks really big and it looks bigger than my right angle. Let me just draw a right angle here. Okay. And 135 is definitely larger than 90, so I know that that's a reasonable answer. Now, if I look at the other two angles that are left on this triangle here, they look really small. They're really tiny, definitely less than 90 degrees, okay? And I'm not going to measure them because we're going to name this triangle based on its angles. And the fact that I have one obtuse angle already tells me the name of this triangle. And if you go back to page 916 in your book, right here, if there is one obtuse angle and two acute angles, which is what we have, we call that triangle obtuse. Obtuse. Because of this angle right here, it gives us the name obtuse, okay? So to recap, naming triangles, you can name them by their sides or by their angles. If you name them by the sides, here are the definitions. Two congruent sides, here and here, gives you an isosceles triangle. If all the sides are the same or congruent, that's called equilateral. And lastly, if all the sides are different, that is called scalene. But if you want to give a triangle a name based on its angles, if all the angles are less than 90 degrees, they're called acute triangles. If you have just one right angle, you don't even have to worry about the others, the triangle's name is a right triangle. If you have one very large angle, which is obtuse, and then two acute ones, acute angles, that is called an obtuse triangle. Okay? So hopefully that clarified for you how to use the protractor and then how to also name triangles based on their sides or based on their angles. So now when I give you this paper for tonight's post, you can go ahead and more easily identify each of the triangles. This 1 through 3 you need to identify based on sides. 4 through 6 you need to identify the triangle or name it based on its angles. And lastly, you're going to measure these triangles here to find the unknown angle. But wait, do you actually have to measure them? No, you do not, because you're given 2 of the measurements already. Now down here it's asking you to use a protractor and ruler and draw these out. I'm going to ask you to cross those out because I know some of you have that very expensive makeshift paper one, and that's very difficult to do with a paper protractor. So when we get back to school we might revisit that, okay? But wait, what is this mixed review? Oh, adding or subtracting fractions and mixed numbers. That sounds good. So I'm going to ask you to do that just to refresh your memory, because we did do that. So on this assignment here, I'm asking you to do the whole enchilada. Where's that paper here? Whole enchilada minus numbers, whoops, make sure you see that, minus numbers 10 and 11. Okay? All right, good. Now, real quick, this week you're also going to have to identify quadrilaterals. And from last week's homework, we learned that a quadrilateral has 4 sides because quad means 4. So a quadrilateral is a geometric figure that has 4 sides and 4 angles. But there's different types of quadrilaterals. Here, just a freehand sketch, is a quadrilateral that is a square. If you have a shape that looks like this, that's a rectangle. But they're both quadrilaterals because they both have 4 sides and 4 angles, okay? But quadrilaterals have different names, just like triangles, based on their sides and their angles, but also some different ideas here. So what I did is I printed out for you 2 terms that you're going to need to know that are going to help you identify quadrilaterals. So the first idea is parallel. When lines or sides of quadrilaterals are parallel. Parallel means that if you take the sides and you continue them on, the sides will never touch or intersect. And you can know this by measuring the distance between the sides. So if I take this set of parallel lines and I measure it, it's about a ½ centimeter here. And if I go all the way down here, it's also a ½ centimeter. So if I continued these lines forever in both directions, they would always be a ½ centimeter apart. They would never touch, they would never cross, they would never intersect. Those are parallel lines. If I draw a makeshift square here, that's not very good. And I continue the lines of my square, these are also parallel lines. They will never touch. They will always be the same distance across from each other if I continue the lines forever, okay? So sometimes quadrilaterals have parallel lines. If I have a quadrilateral that looks like this, that's a quadrilateral because it has 4 sides and 4 angles. But if I continued the lines of my quadrilateral, eventually they would intersect here. And so that means that these 2 lines or sides are not parallel. Okay? So keep that in mind when you get to the assignment about naming quadrilaterals. Another term that you need to know is congruent. And congruent I've been mentioning before, but just to remember, means of the same size. Same size. So right here, lines AB and CD, if you look at them, they're exactly the same length. They are congruent. the next set of lines here, A, B, and E, F, they are not the same size, so they are not congruent. Angles can also be congruent. So here I have two angles that have a measure of 42 degrees, and here. Those are acute angles because they are less than 90 degrees. But since they measure exactly the same, these are congruent or the same. Okay? So congruent and parallel are two terms that you're going to need to know. I think this will be Tuesday's assignment where you're going to need to know those two terms. Okay? And at any time you get confused, you can replay this very, very exciting video, or I will post some Khan Academy instructions if you'd rather look at those, or you can always email if you have questions, okay? But what I want you guys to remember is that don't just try to get the work done quick. You guys have to make sure that you have an understanding, and it's hard for me to know if you understand when I'm not there watching you do the work, okay? So make sure that you understand and don't just say, oh, I got it done and now I can go do something else. It's really important that you get an understanding because you will see this again up one notch in 6th grade, 7th grade, and so forth, okay? All right, so to wrap it up, let me bring my right angle llama here. Why is he called a right angle llama? Hopefully by now you figured it out. If I take my protractor and I put the vertex right at put my protractor on the vertex where his back and his neck are, and I follow his neck going up here, it is about, let's see, I can get this all in the frame. Well, it's really hard to see on the table here, but if I follow his neck up all the way, it is about 90 degrees. Not exactly, because, you know, he's something found in nature. I didn't draw him. But I hope, especially Gianna, who loves llamas, will use this to help you think about what a right angle is, okay? All right, so we'll see you guys on another Zoom meeting. Those of you that are doing the Ben and Me project, we're going to meet on Thursday. There's still time to do the Men and Me project. If you want to do that, we'll have a Zoom meeting on Thursday to go over your product. But at any time you need to talk to me or contact me, please email, okay? I'll see you guys later. Bye-bye.